Wonder if that. Ooh. Huh, that might be better.
We'll look for the red.
It's recording. And
Okay.
Somebody wants snackies early.
Yep.
We're waiting for YouTube.
Yeah.
Okay, we have a problem here. Just let me bear with me.
Somebody call Houston.
Yeah, there was one week we had about 4 people on the YouTube, but lately it's just been just one. That's it, and it's me. Well, there be people, they jump in and then jump out again.
And some people just watch it later.
Yeah.
Oh, okay.
Uh-oh, it says I'm not enabled for live streaming.
But we are recording.
Yeah, we are recorded.
Okay. Shall we launch?
Not yet. Wait a second. Huh. Oh, down to the last thing and it won't let me do it.
Huh.
It says we're connected. Go live.
Oh, let me see if I can find it here. I have to refresh the page.
Maybe they rejected us. They don't want our programming.
Somebody else's tube.
No, I need Tom. I need Tom on this.
Yeah. Well, say when.
Let's see. Get out of this.
Yeah, no, we're not live on YouTube. Did you text Tom, Jerry?
No, I'm just about to.
Yeah.
Jerry Wilson, what's going on?
Hi, I'm having trouble getting to be live on YouTube. Says I'm not authorized.
Oh, did you log on to YouTube ahead of time?
No,
You gotta log on to YouTube ahead of time.
that's what I'm stuck in the middle of, is logging on to YouTube.
It's not taking the password, or
No, it says verify it's
SBAU?
no, it's giving me jerryawilsongmail.com as the email address.
So you need to change that. You can go up the upper right and click on your little J there. I don't know if they give you a little J, and then say add account or use different account.
Add, okay.
And it's a new computer, Tom.
Yeah, this is a brand new computer.
Oh, yeah, that didn't save it for you.
Yeah.
So put in the proper address and password.
Okay, do you know those offhand?
Not offhand. I can try and look them up here on my phone.
Okay,
Let me-
could you get on and start the meeting for us?
I'm at the supermarket right now,
So the answer
my
is
cell phone.
no.
so probably not the easiest thing to do.
If you mention credentials, we'll be recording it here.
Yeah, we are recording it to the cloud.
Okay, yeah, the Zoom. So I mean, that's one thing. That's
Yeah.
we can always put it on later on, but
Yeah. Okay,
nice to have it live, I guess.
yeah,
If you want to wait. LastPass is trying to log me in here. So why don't you just skip going live and just record it, and we'll put it on afterwards.
yeah, that's
Might
what
be
we'll do.
easier.
Okay,
Okay,
thank you.
you bet. Talk to you later.
Bye.
Bye.
Okay,
All right, by golly, as we
So-
live and breathe, and some of us still are. Doggone
So
it, it's
skip
time
YouTube.
once again for our special weekly vlog on Mondays, 11 to noon. We're a little late. We're not on YouTube at the moment, but we will be, and we call it the SBAU Astro Hour on behalf of the Santa Barbara Astronomical Unit, your South Central California Coast Longtime Astrophysics and Telescope Club, based at the Santa Barbara Beautiful Museum of Natural History up in Mission Canyon, where SBAU holds our first Friday of the month general meetings, 7:30 p.m., as we will this week. It's turning into May and May 3rd. We also host a very popular outdoor star party every month, starting at dark right next to the museum's Palmer Observatory on the second Saturday. You're invited to join us. If you're interested in astrophysics, you don't even have to join the club, though we'd love to have you with us. Check us out on sbau.org and watch us usually live, sometimes, not today, on Monday. What is today? The 29th of April, 2024 through May the 5th. It's program number 166 of the Astro Hour, and I'm your host, Vice President of the club, Ron Heron. I'll introduce you to the rest of the board. Stand by to meet them. In the meantime, here's what we're going to talk about this week. Going to do some star hopping, show you exactly how to find the faint ones up there. Talk about your basic scopes, your telescope mounts. We're going to dissect the reflecting telescope, the catadioptric telescope. Wow. A moonless dark sky dead ahead. And what in the heck is the ghost of Jupiter anyway? Ooh, tonight, to the left of the North Star, a camel in the night sky, Camelopardalis, I guess, another meteor shower headed our way. But first, according to your talking points, Mr. President, we get through Halley's comet tail. Does that mean we have two meteor showers? Let's meet the
Yes.
guy in charge, Jerry Wilson. 6 years of beloved presidency of SBAU, Jerry. And he and his wife, Pat Forgy, happen to be the incredible godparents of the man who sat there and did the joystick on the Ingenuity helicopter on Mars. We'd love to get him on someday. Martin Kachak? No, what is his last name?
taken.
Kakin. Here's our incredible outreach coordinator, Chuck McPartland, with his cats in front of the Ukraine's flag. And Pat McPartland is his wife, the merchandise manager, as well as our new treasurer. Joining us online is Tim Crawford, who's married to Karen. He is a longtime stalwart member and a telescope expert, and is going to add a lot to the hour. The editor of our incredible monthly newsletter is Tom Whittemore. He's on the screen there, at least the top ahead of him. Maureen is his wife, former Westmont College professor. And we do sillies. We have silly cartoons, science cartoons that I just pointed out earlier as we were talking on screen. Our 3+ years now going on is a heck of a repository of cartoons. If you were to go back, there's got to be thousands, most of them with a scientific aspect to them. So here we go. Bring that up. Oh, is that the fractal lawn? Okay. One guy sees his friend trying to edge his round lawns, and for some reason they keep growing as he trims. This would have done better as a moving animation, you think?
It would take you forever.
Yeah, well, I
The
know.
definition-
I've seen a few fractals, and they do go forever. What does he
Yes,
say?
they do,
Hey,
literally. Fractal means fractional dimensional. So this object here would be a 2 1/2 dimension figure. And
So
what
there-
the definition of the mathematical definition of it is it's a finite area surrounded by an infinite circumference.
A finite area, infinite circumference. So he's on the large one that keeps growing, and the one above it looks like a
The
snowman.
detail, there's finer and finer detail around the edge, and eventually in the limit, it adds up to an infinite line length. But
Yeah.
it surrounds a finite area.
And this particular shape is the Mandelbrot set.
Yes.
And it's what's called self-similar. Also, fractals often have what's called self-similarity. So as you zoom in on the edge of this curve, you see repetitions of the Mandelbrot set within the Mandelbrot set. So it just basically zooms down forever.
Right. You will
There was a-
always see more details.
And there was a scientist named Mandelbrot.
Yeah,
Yeah,
the
it's a
mathematician.
mathematician.
Okay, well, quickly, that one guy catches him and says, "Hey, the lawn looks great." And he says, "How long does it take?" And he says, "It feels like it takes forever. My God."
Yes, he's edging it.
Okay, this is not like crop circles. All right, I remember this one. This happens on every team. You got the kids, even when you're being disintegrated and moved up. Beam me up. Are we there yet, Dad? Okay. That's an ancient one. That's several months old there, Jerry, but finally got it. Thank you.
Yeah, we're getting through the pile. We're mining them
Okay.
for good ones.
On the spot is how you headlined this when you sent it to us. Earth's formation site. It's a bubblehead, a stick figure apparently found the very spot where in the year 4,450,000,000 BC, a cloud of dust and gas gravitationally collapsed upon itself to form Mother Earth. There it is. I wonder if it's in the same spot on our trip around the black hole in the galaxy. This one you said it was called Ouch. Either an octopus or a multi-tentacled cephalopod alien in the hospital bed, having had several of its arms removed. And the two visitors, actually the nurse is talking to a visitor. "We had to amputate, sorry." "Oh no, how many tentacles does he have left?" "Well, 3.14. He's an octopi."
3.14, it's the start of pi.
Octopi, yeah. 3.14. Only 14/100ths of an arm. Boy, baby boomers will get this. Too funny. Oh, I sent you this one. You got to look. She's holding up a phone from the old days. Used to rest on the cradle and aiming at them.
They're doing a selfie of old style equipment.
That's right. We can barely see the phone. Yep, that happens. Next week we'll
Have you
do
seen those sessions or jokes where you set down a couple of millennials and you give them a dial phone and ask them to operate it and they don't know how?
No.
Whatever happened to those little photo booths in Walmart, or not Walmart, but remember you could get 4 pictures of yourself? Oh, okay. Did you want to go by that strange? Oh my God, you're doing all kinds of weird stuff.
Yeah, I'm just got lost there for a minute.
A couple of 9s are in a room full of 3s, and they say, I suddenly feel kind of uncool. And the other one says, "Yeah, in a place like this, we're just a couple of squares."
Yeah. So 3 squared is 9.
Same thing happens to 16s and
Yeah, in a
4s.
4 room.
Yeah. Okay, is the stair up or down? Is the stair to nowhere? What are these called? That's not a fractal, is it?
This is called an Escher staircase.
Ah,
Yeah.
It's
Just
got
one
one
thing.
surface and one line.
Oh, Bruce is
one
on board.
surface,
Bruce
actually.
Murdoch. You came in too late to get introduced, but can somebody build a staircase like this?
No,
Can't be done?
you
Look,
can only
look
draw
from side to side. You can't build this physically.
Okay. But you can sure have fun with it. All right. These are a couple of intersections. One is the crosswalk, and the other is if you're not cross, you're happy, the happy walk. And then there's the blase walk in between. Okay, got stuff to talk about. And Bruce, are we not going to be able to?
Bruce, you're causing us feedback.
I am? How?
You're
I don't hear feedback.
feeding back. I'm hearing it. Everything we're saying gets fed back. coming off a cough, but I'm ready to learn. Yeah, we're gonna have to pull the plug on you, Bruce. It's called mute. Oh, maybe mute won't know. That's on my side. There we go. You did it. Sorry. Think he took offense. Well, where are we? In the night sky, Mr. President. That's a great way to start.
Oh, yes, this is right. This is the section on star hopping. We have covered this a little bit before, but it needs more discussion. It's probably the best way to get familiar with the night sky, in my view. There's a big trend, as everybody knows, for Go-2, where the machine knows everything. It has a complete planetarium built into it where everything is. But it's nice to look at the sky and see old friends up there and know your way around. And so there's a few things that you can help yourself learn the sky with. And this is an example. There's 3 topics that we're going to cover. One is recognition of the sky. The other one is how to get to faint objects. And the third one is how to get to faint objects with a telescope. So those are 3 different applications of star hopping. This one is to recognize the sky. And this picture covers a lot of sky. This is the Big Bear, Ursa Major, the Big Dipper. This handle here is the plow. And at the end of these are bright stars, and this is a very easy constellation to spot. It's right around the North Pole. And you know, these stars here are called the pointer stars, and they point right to the Polaris, the North Star. So for us in the Northern Hemisphere, this is always up if the sky is clear. And what
Can
you
you
can
tell me
do,
what are the most faint things to see? Star clusters, distant galaxies, red?
distant galaxies are probably the faintest. Nebulas are spread out. So even though you see a nebula is listed at 8th magnitude, which is invisible to the naked eye, it still implies that it's fairly bright, but it's spread over a large area. So those are what we call faint fuzzies along the galaxies. And but stars and star clusters are the easiest to see.
We've got the feedback again.
Okay, I had muted myself. Is it time delay feedback? What's going on? I just
Yeah.
It is time delay.
It's about, half-second time delay.
Huh. That's strange. Anyway, I'll get out of here and come back in.
Yeah, relog in. Bruce. We'd love to have you on board.
How do I get out of this?
Okay.
Just out of curiosity, Mr. President, all of these different faint things, some of the faint things are logged. They could be either an M or an NGC, which encompasses both star clusters and distant galaxies, and sometimes a star, right? Or do
No.
some of them just relegate on star clusters alone?
No,
and
that's a little off topic, but we'll cover it right now. As astronomy has progressed from before telescopes and then up through primitive and poorly functioning telescopes, up to bigger and better telescopes, and now up to gigantic telescopes and space-based telescopes, we can see fainter and fainter objects. And in each of these eras, people have started lists, their own lists or catalogs of features. And Messier had his 110 objects for his own reasons. He was trying to identify, because he got money from, those days, the 1600s, 1700s, they got awards from kings for finding comets. And so they wanted to speed the process up. So he listed all the things that he thought could confuse with a comet. Then later in the 1800s, Herschel did his new general catalog, which is about, about 8,000 objects long. And he was looking through, for that time, very large telescopes, 76 feet in diameter mirrors. And eventually, and actually Catherine, his sister, put the whole thing together.
Carolyn,
yes, good, thank you. So
do we have feedback now?
What?
Do we have feedback now?
well,
I
let's
don't
see.
hear any.
No, I think you
I just
fixed
closed
it.
the application and then reopened it.
Okay. And now we have telescopes that can see fantastically deep, and so that they have their own listings. There's the IC catalog and the Caldwell catalog and a number of other things. So those are just people's lists of things. But we're dealing with pretty much NGC and Messier objects, the M's, because those are the brightest ones, and our scopes don't reach past NGCs or M's unless you do long photographs. But here we're just looking right now at naked eye, what you can see, the patterns that pop out to your eye when you see the sky and to get around. And people ask, what's that star? Here's how you can learn those things. So this is the handle of the dipper. And you can draw a line from Arcturus. See, the handle has an arc to it, and the arc goes down here to Arcturus. See arc there. So it arcs down to Arcturus. So the star down here, this is quite a ways away. That you set that up in your mind as a line, and then you do 90 degrees from that. And that gets you up to Vega, which is part of the summer triangle. So you know you're looking for a triangle of the very brightest first magnitude stars. And so that allows you to identify which is Altair, which is Deneb and Cygnus, and which is Vega in Lyra. So this is an example of using geometries, and there are patterns like this all over the sky that help you get around.
And you can tell it's a British map because it says plow instead of Big Dipper.
Yes, yeah.
Oh, that was going to be my question. What the heck is plow? Okay, got it. They call it a plow. It's okay. It looks kind of like a plow.
Yeah, some people call it a wagon. I think in German it's wagon.
Does that help? But plow is spelled with a W, I thought.
For an
In
American.
America.
Yeah.
Oh, okay.
So you'll see in a lot of the directions that we talk about, at least in the printed directions, the talking points we call them. We're not going to say them too much this way, but you'll look for something that is, say, 10 degrees south of Jupiter. And this is how you do angles on the sky. You put your hand out at arm's length, and your finger, the width of your pointer, is between 1 and 1/2 degree, depending on how fat you are. And then this is the size of your finger is, and this is the size of your hand. And this goes between 8 and 10 degrees. I was told 8 degrees when I was a kid, but I had smaller hands. Now as an adult, it's 10 degrees. And then sitting your hand like this, which I think is something to do with surfing. That's 20 degrees. So you can put these up and you can look at the stars and you can see, well, let's see, 20 degrees below Jupiter, that would be down about here. And so it helps you get around the sky. Now this one is again what we were talking about. This one is Polaris, or rather the Polaris is there, the North Star. This is the Little Dipper. This is the Big Dipper again. And here we go through the pointer stars to Polaris. And then we go at a slightly oblique angle up here, and we go to the constellation of Cassiopeia. Now, these are roughly opposite each other around Polaris in the sky. So in one, but these are both circumpolar. If you have a good horizon, and around here in Santa Barbara at 34 degrees north latitude, you can pretty much see these things all year. But one of them is going to be scraping its keel on the horizon, and the other one will be right above Polaris. So one of these will be up and one of them will be down. So this is the characteristic W or M, depending on the season. And this is the characteristic dipper. So these patterns, a lot of these other things are very obscure patterns. We'll get to some of the most obscure in a moment.
Have you been able to see these things clearly at night? I can't.
Lately?
Yeah, lately, like last night.
No. We had a
Okay.
hazy night here last night, and it was very wet. So but you can't see the, anyway, we'll get back to that. Now, this is the winter triangle, Betelgeuse, Procyon, and Sirius. Sirius is the brightest star in the sky. Now, these things, picking out a triangle from the brightest stars are pretty easy. Your mind wants to find these kind of simple geometries. So if you go from Sirius and you find Orion, which is a very easy to spot constellation also, and there he is with the bow. Sirius to the belt of Orion, and then right straight on over to the core of Aldebaran, this bright orange star. And this is the Hyades cluster, a very big cluster that you can see with your naked eye. So this is an easy way to find that. Now, Tim has a star hop he suggested here, and I'll let him describe that.
Yeah, there's several. This is Cygnus, the swan, and there's several.
Yes, Cygnus is here.
Right, and a lot of people call it the Northern Cross. And when you view it that way, you can see Deneb at the top, and then Albireo at the bottom, and then the other stars, I don't know their names, but they cross through a central star. And just real easy right now, the 6888 is the Crescent Nebula. If you take that center star of the cross and go straight down that, hard to see that yellow line, but you'll run right into the Crescent Nebula. You'll need a filter for it. But these are really oversimplified ways that I find targets in Cygnus. The one that I use a lot that's really neat is you go from Deneb through that corner star of the cross, and it points directly to 52 Cygni, which is just right in the heart of the Witch's Broom, or I think it's the west
down
wall.
here is the number 52. I know it's hard to read.
That's it.
And right where the arrowhead is, and that is these are the Veil Nebula, all the parts of it. There are 3 parts, and you can get, if you have a low power scope and a wide field scope, you can get all these in the same field of view at once. They are faint, but you need a dark night. But this is the perfect start of the next 2 weeks, is very dark skies. Now let me go back to this, the length of the arrow that Tom has drawn here from this star in the middle of the cross down to the Crescent Nebula. The Crescent Nebula is right there at the fingertip, right at the head of the cross or the arrow. Okay, Tim, go ahead.
Yeah, those takes care of those two. Now, one of them that I have a trouble finding is the Dumbbell Nebula, and the one that Chuck said he's named after, and that's down where Jerry's cursor is. And what I generally do is I use the 2 stars of the upper cross and then Albireo as 3 corners of a rectangle. And the 4th corner should be very near the dumbbell.
Yeah, right.
But
there.
again, I have a little bit of a hard time. Now, somehow you're supposed to be able to use Delphinus, I think, to point to
Sagitta, off the tip of Sagitta, the arrow.
Okay, and so you can use Sagitta and then this rectangle technique to try and find the dumbbell. Lastly, well, not last, but the other one that I do quite a bit in the summer is the blinking planetary. Now that's up at the wings of Cygnus. It's up at the top of this image. Now there's 2 stars there, one there and one there, and they're fairly obvious naked eye. So you go out about equal distance, but you kind of arc a little bit to the right. And right about in there is where the blinking planetary is. And it's when you locate it, there's 2 brighter stars that are really obvious. They're like 2 bright eyes that you're looking at through your telescope. Now, depending on the kind of diagonal the diagonal you have, or the type of telescope you have to kind of look around in a circle. It could be below or it could be above, but all of a sudden you'll see this puffy little greenish blue dot. And that's the blinking planetary. A little hard to find, but that's the star hop I use to get to that blinking planetary. What is that, Tom? Is 30, what is that?
6888.
No,
68.2 something.
20 something, yeah.
Yeah, okay.
6826. Does that sound right?
That
It
sounds
could be
good.
that the arrowhead is covering the 6.
Yeah, and so anyway, and lastly, when you go down to Lyra, you know, there's a parallelogram. Yeah, and there's Vega, the big bright star. You can't miss it.
Yep.
Off to the right of Cygnus, and just below and towards Cygnus, you're going to see a parallelogram of stars. And if Jerry, if you could point those out, that it's just the 4 brighter stars here, and it's just a parallelogram. So on the side of the parallelogram, away from Vega, right in the middle is where the Ring Nebula is, and that's how I find those. And Ring Nebula is really, it's much easier to find than people think it is.
Mhm.
And
Now, the trick with finding planetaries is when you do this star hopping and looking around and following these mental arrows that you put in the sky, you're going to be using a low power eyepiece. And the planetary nebulas are going to look just like a star. So you have to get in the right area and then switch to a higher power eyepiece, and then the planetary will magnify, the stars won't.
And there's many other targets in Cygnus, around Cygnus here, like the North American Nebula up there, Jerry, by Deneb, to the left of Deneb. And
Now, when I go
the
to
North
photograph
American
things,
Nebula, and
the
that's
what?
a
Pelican.
yeah, Pelican and North America.
Yeah, that's in here. Oh, this is up here.
That's it right
North
there.
America. You can see the Gulf of Mexico here,
Yeah,
Mhm.
and the Pelican here with the long bill sticking down there.
that's it. So there's tons and tons during the summer months. This is one of the things that at a star party that's kind of a premier place to go.
Right.
As well as
Now, you see
Sagittarius.
this blue background, this robin's egg blue background, that's the borders of the Milky Way.
Yeah,
And
yeah.
these white areas are actually dark nebulas that are obscuring star clouds in the background.
Yeah.
Out here, this is because you're looking out of the disk of the galaxy and you see out into in intergalactic space. We'll show that a little more later.
You
So
suppose,
when I go to photograph things, I make finder charts by Xeroxing or printing out from a software planetarium program the wide field view of my target and the narrowed in field of my target, so I can identify the stars around it. Because when I'm setting things up, I frequently cannot see the object I want to photograph.
And I might mention another star hopping that it's built into. I don't know if it's in the sky, but I think in Starry Night they have a way of putting a Telred finder into your image. So whatever you might want to see something in the planetary software or in the software, and then you can put that Telrad and superimpose it over your chart that you're going to be looking at, and count so many of the Telrad views away, and that's a way of people using a star hop as well.
A Telrad is an instrument you put on your telescope, like a finder scope, that projects a red dot on the sky for you.
Yeah, or a circle.
Now, when you set up for public outreach, which is a major focus of our club, you either spend time aligning your telescope with the true north, or with True North and Polaris, or I set it up approximately. I usually am a little later, and so I see how Chuck set his up and I copy it. And then when you go to set it up, it won't be accurate for go-to, but you put a laser pointer mounted on your tube, and then you point at these things and you can see where you're going. You can actually draw the lines on the sky with your green laser pointer. And I find that faster and more accurate to find an object than trying to use go-to.
Yeah.
Okay.
well,
Now,
speaking of telescopes, are we going there soon? We're back to the sky.
next, yeah, we're segueing into it.
Okay.
Okay. Now, suppose you want to look at something that's faint, like, oh, it just went right under there. It's Abel 39 and it's faint. So you want to find that. And so this is an exercise you do, or I do on a star chart the day before or during the day for that evening. And you start with something that you know, a pattern that's there that you can find, like this pattern. And then you move, you make on a clear plastic. Many star charts catalogs will provide clear plastic sheets with circles drawn on them for different fields of view on your telescope. And so, for example, this would be at a, say this would be a one, typically you get a 1 degree or a 1.5 degree or sometimes 2 degree field of view. And so you center that field of view on your starting field, and then you pick something at the edge of the field of view, like this star. And then you move the field of view that way until the star is close to the other edge, and you mark the distance that way. Then you've found another object, and you've picked stars at the edge of the field of view, and then you move your telescope until those stars are near the other edge of the field of view or a definite distance away. And then you can do that, say with this star, and then you move over, and then you know where to look in your field of view for the object you want.
Huh.
So is that clear, or how to do it? Because you know you're gonna, you have a field of view, say 1.5 degrees. And if you move a star from the left edge of the field of view to the right edge of the field of view by moving your star, you've moved over 1.5 degrees. And you can count off these number of fields of view in one of the 2 directions that your mount provides. If you're using a German equatorial mount, which is like this mount, then it's an equatorial mount, then your 2 axes are right ascension and declination. If you're using an alt azimuth mount, which is a camera mount, then it tilts up or down, and it tilts sideways around the horizon. Those are your 2 axes there, and you need to figure out your motions on the star chart for the axes that you have. The star chart will be divided into right ascension and declination, and it's easy to figure out what altitude and azimuth are too.
Huh.
And this is a form of equatorial mount, but it's a fork mount. This one, you want to line the polar axis up with the North Star, and most of them are supplied with the polar scope that lets you look through this axis. I don't have any fork mounts. You can't see Polaris directly through that polar axis. So I'm not too sure how to do that alignment in a simple way. But this is a very common mount too, the Dobsonian mount, which is an alt azimuth mount. That is, it swings around this way. Usually they use an old vinyl record or something down here for the bearing, and then it tips up and down with this. And so you have to make these motions on your star chart and mark them down so you can do them that evening. Does anyone want to tackle how to do polar alignment with a fork mount?
What I do is set my, I have setting circles on my fork. And so I first go to some star with a known right ascension and roughly set the right ascension to the current where it's pointed. Then I set it to the right ascension and declination of Polaris, which is 8916 for declination and 246 for right ascension. And then I physically move the mount, the wedge up and down in declination until Polaris is roughly centered in my finder field of view.
Okay.
And then go back to whatever star I use for right ascension and reset the right ascension now, because I'll get a little better value. And you go back and forth between a couple of stars and maybe do one on the west and then one on the east. And after 4 or 5 iterations, you've got a pretty good alignment.
Okay, thank you. Oops.
Question about the early days back in Galileo's time. They didn't have trackers, did they?
No, they had basically this,
They had what?
this.
Oh,
Altaz.
what we're talking about, so
Altaz.
they'd have, how often do you have to move it back, you know, with, if you didn't have a tracker, how fast does the earth move? Were you talking about every 5
15
minutes?
degrees an hour.
Goes around
Depends.
once every 24 hours.
It depends on the field of view of your eyepiece too.
Yeah.
Oh, yeah, that's true, okay.
And they pretty quickly in the 1600s had tracking mounts because they were already using right ascension and declination type coordinates.
Yeah. They had
Tracking.
mechanical clock drives, they called them, and they were powered by falling weights, just like a grandfather clock is.
If you're doing an outreach, you know, like say when I'm working with Tom Whittemore out at Westmont, we'll put a low power eyepiece in because, you know, we basically are using a Dobsonian out there, which is push to, and you always have to reset what you're looking at in the center of your view. But the low power allows you to go longer between
Yeah.
you know, all your customers. But if you put the higher power in there, it will really move fast.
Right.
That's
just,
because we're rotating at 700 miles an hour toward the east at our latitude.
yeah, just a tidbit. I often use the scope on the right, Dob. And like Tim, I have an 8-inch telescope, actually the first telescope I ever made. And for my little vinyl record on the bottom, I purposely chose Interstellar Space by John Coltrane.
I didn't know that.
Yeah,
Yeah, that's a neat scope too, Tom.
That's a hard
thank you.
record to get.
yes. It's easy to get. You have to just take the telescope apart.
Yours, yeah.
Yeah, it was a little hard to play though.
It's scratchy.
Uh-oh. This looks
Now,
like
this is an illustration that shows the function of a polar scope, equatorial mount, is that you line it up so the polar axis of your scope is parallel to the rotational axis of the Earth. This
Really?
is from a BBC paper, and I don't know what SCP means there.
That's South Celestial
Yeah.
Pole. So this
Oh,
is
that's right. It's an
Australia.
Australian BBC thing. Yeah.
Yeah, the other
Okay.
side.
Good catch. So pointing, it looks like one point's over here and one point's over there. But remember, effectively for these size of instruments, this distance is infinitesimal, it's super small. So pointing at the same object gives you no parallelism error. But it's just once you line it up, it's just one rotation that corrects the Earth's motion. And as was pointed out earlier, they established mechanical clocks very early to drive telescopes.
So we do have an NCP as well, I guess.
These are the common scopes that we
Close to
use.
Polaris.
What's
Yeah.
that?
I was just going to say very close to Polaris is the NCP.
So the refracting telescopes were the first ones, very poor quality, but they got much better. Biggest one ever was 1880s in Yerkes Observatory, a 40-inch. There was a 60-inch built in Paris, but it never really worked out.
Yeah.
Reflecting telescope, probably one of the most common ones for amateurs to make, single mirror, flat mirror projecting the light to the side. And the common one for fork mounts nowadays is catadioptrics. These are Meades or Celestrons. Celestron people will tell you that Meade is a good paperweight. So it has a corrector plate. These are very cheap to manufacture. All the surfaces in here are circles or spheres.
Spherical.
Easy to machine make. And then this corrector plate has a funny shape to it. And but that, it turns out, is very easy to make too. It's a thin piece of glass. They distort it by putting it on a vacuum plate, sucking it down, and then grinding the front flat, and then they release the vacuum and it's automatically to the right shape. So it's
I'll be darned.
manufacturable.
Yeah.
That's for a Schmidt Cassegrain, but you can also have a Maksutov Cassegrain where all the surfaces are spherical.
Yeah.
Yes.
And the fellow who
But they're
invented
heavy. I have my 5 inches is a Matsutov,
yeah.
and the front corrector plate is a half an inch thick glass.
Whoa.
Yeah,
Yeah, they take
those are-
longer to thermally stabilize and they're heavier at the front.
Yeah, they're very heavy at the front. And Meade sold a 7-inch F11 one once. And they had to put so much lead at the back because they wanted the eyepiece to be down close to the mount, close to the axes. And the thing was just murder to lift.
I bet.
But those are the common scopes. Now we take advantage of our dark skies and look at, oh, where's my thing?
On the positive side, my Matsutov, I don't think I've ever had to collimate it.
Yeah.
It's just really robust. You can,
Mhm.
move it around and bang it and whatnot. It just sits there and works.
Now, this is MGC 3344, which is a galaxy. It is the, let's see if it has a name. Oh, the sliced onion galaxy. Kind of catchy. It's above Leo. These are in the evening sky right now. If you could see the evening sky, we have a lot of marine layer this time of the year. This is the sliced onion right there, where the cursor is. This is Leo Minor, the little lion. This is the big lion with Regulus down here. So we're above the back of that lion. And this is a very nice object. It does not have an M number, so you can tell it's not that bright. It's about 20 million light years from Earth. This image is through a bunch of different filters. And it covers wavelengths from ultraviolet to the visible and into the near infrared. These red things here are clouds of neutral hydrogen where stars are being produced. So the galaxy in images tends to have a bluer outer region and a yellowish inner region.
Would those be nebula?
What's that?
Would those red regions or hydrogen star-forming regions in a distant galaxy?
Yeah, they would be, for example, this would be something like the Orion Nebula or
Okay.
the Veil Nebula. Well, this would be the Orion Nebula is where star forming is. The Veil Nebula is where a nova blew up and blew all this crap out.
Huh.
Now this shows a planetarium software, the SkyX, where we backed up completely so that we're not magnifying the sphere of the night sky, although we're still looking at from the inside. And you can see all of these things, all this features around here, and then up here and around. And this is the Milky Way going around there and around the other side. And so what we're doing right now, we're looking, our night sky in this time of the year is looking in this darker region. And this is looking out of the North Pole of our flat galaxy, roughly flattish galaxy. And this is south from us. So Herschel 27 is actually NGC 3242, and it's called the Ghost of Jupiter.
Oh,
It's
yeah.
It's down in this Hydra, that's where it was. This is the constellation of Hydra stretching along there.
That's the biggest constellation in the sky.
Yeah.
Okay. It does take up a lot of space.
Yeah.
I had to go to
Is
this.
that a good target for, at a star party, or is it fairly small, obscure, or is it just for imaging?
Pretty bright, and you want to hide. You want a
Give it a try.
you want
Yeah,
a
yeah.
filter.
I was
You
just
want a
going to
nebula
say,
filter.
Tom, but Tom, I think this might be a Westmont target.
So this was discovered by William Herschel in 1785.
Wow.
And
What's its common name? I missed it.
Ghost of Jupiter.
Oh, the ghost. Okay. Oh.
now it doesn't look like Jupiter in this Hubble photograph,
Yeah.
but if it in our amateur scopes, it will look like Jupiter. It gives the same shape and roughly oblate size.
Huh.
and similar color, but no bands. It's a fainter object.
No shell around it.
Are those red things
Oh, that-
in
that-
orbit around it?
That is the shell.
No, the red things are where it has jets coming out of its rotational axis.
Okay.
So. Okay.
Ghost of Jupiter. We should save this and come back to it in October, Halloween.
Then it's not nicely placed in the sky.
Right.
Oh,
Here
okay.
is one of the most interesting constellations. It has a lot of territory, even to the other side of the North Pole, but not a lot of stars. The whole thing is a giraffe with these two stars.
Camelopardos.
Yeah. You'd think it might be a camel or something, but no, it's a
It's a
giraffe.
giraffe.
Yeah.
Spotted
Well,
giraffe.
Spotted camel.
Mhm.
One
I
of
was told
two.
it a spotted giraffe, and then that funny story I had with you, I always called it Camelodarpalus. Chuck corrected me over and over until finally said he got me to say it really slow, and I said, "Okay, Camelopardalis." He said, "Yeah, it's a giraffe," and I said, "Yeah, it's a giraffe."
Are they related, do you think? Camels and giraffes?
Distantly, yes.
Yeah.
Okay.
We're all related.
Yeah.
They're both full on hoof.
So
Yeah, right
NGC
there, Gary.
NGC 1502 is a star cluster.
Yep.
And it anchors a asterism in the sky called Kemble's Cascade,
Absolutely.
which is not enumerated here on this plot,
Yeah.
but it looks like this. This is the cascade, and this is the star cluster 1502.
A little splash of water, I say.
Yep.
Yeah, a little splash of water.
I always viewed it as like a slow motion image of a pebble dropping into a brook,
Right,
and the brook 1502 at the bottom.
right. Nearby is 1501, remember, Tim?
I can't remember that one. Is that
It's just a nebula. It's
yeah,
pretty.
I
It's
think
pretty.
we looked at it.
Mhm.
It's a big empty spot in the sky, and it's really
Mhm.
good to tell people you don't really need telescopes a lot. This is something that
That's-
that a binoculars
yeah.
are perfect.
That's a really nice binocular object.
Absolutely.
Yeah, Kemble's.
So this is that star cluster at the edge of Kemble's Cascade in infrared light. It's not
Okay.
significantly different in visible light.
Wow.
It only has what is it, 100 stars or 80 stars or something like that?
I think it's 80.
Yeah,
I think.
I think you're right. That's the number I seem to remember.
80 stars, but they're all gravitationally bound to each other pretty much.
Not very loosely, yes. They feel each other's gravity, but the dominant feature of them is they're each in a separate orbit around the effective core of our galaxy. So they will be drifting away from each other over time.
Oh, I know what I can do here.
I wonder if they'd call that beehive of fast-moving stars around Sag, which is our black hole at the center. Is that a star cluster?
I wouldn't classify it as that, no.
I know we see them by radio waves only, but still,
Yeah.
that's crazy in there. Okay.
Now, up in Camelopardalis, there is NGC 2403, which is a very nice and stunning galaxy. It's reminiscent of M33. It's got very large and well-resolved hydrogen H2 regions. This one up here, this is 2403, and this region up here is 2404 all by itself, NGC 2404, the largest one there. And M33 does this too. It has these big star forming regions in it.
Jerry, Wikipedia, by the way, 1502, they say it has approximately 60 stars.
60,
So,
okay.
yeah, that's Wikipedia.
So it's been cleaned out already.
Yeah. Yeah. Sorry, Jerry.
It's okay. Okay, now on May 5, which is next week, we get to the and this is a chart for May 5, but it's counts for May 3 too, except the moon won't be here on May 3 this Friday. Astronomy Magazine recommends you looking on May 3rd, which is Friday in the morning, because this is the tail. These are debris from Halley's Comet, and it's been there so long that it's fanned out, and it's possible to pick up little bursts several days before the shower and several days after. So when we have a new moon on the 3rd, this is the moon a few days after new, then you stand a chance of seeing some fainter meteors.
Oh,
That's a few days before new. Because this is early morning.
Mm-hmm.
Yeah, this is early morning.
Yeah.
Oh, you're right. Yeah, this is the dying moon.
But that's not called a meteor shower. It's just us passing through remnants.
It's
of
a meteor
Halley's.
shower. That's
It
what
is a
meteor
shower.
showers are.
Okay,
But
well,
the
what's
meteor
the,
shower is so broad in time that they want you to start looking on May 3rd, but it peaks on May 5th. That's why they
Okay,
have
so-
May 5.
and it's called the what shower?
Eta Aquarids.
Mm-hmm.
Okay,
Aquariids.
Aquariids. That's a hard word.
now, Halley doesn't retrace itself and go through the same trail every time it goes around the sun, does it?
Not
So-
exactly, no. And the stuff that it has left before spreads out.
Okay, got it.
But we also go through the tail again in October, and that's usually around the time we have our camp out. And that's the Orionid shower.
Okay.
Okay, they don't call it the Halley shower. They don't name it after the comet. They name it after where the radiant comes from. What part
Right,
of
because they had observed this, especially the Orionid shower, long before they knew about Halley's Comet.
Okay, got it. Well,
I didn't realize that you get twice a year.
Yeah.
You get what? Oh, twice a year?
Yeah.
maybe it's two separate orbits that it made.
It's the same orbit, but two separate
Yeah.
Time.
incidents
Hit it
of us
twice.
passing through it.
Okay, well, what do we look at? Which galaxy, Mr. President?
Okay, the galaxy is not the major focus. It's those streaks up above it. That's an
Okay.
undiscovered asteroid. And the reason it's discontinuous and curved is because this picture was a composite from Hubble. There are 4 different exposures, and the aspect of Hubble had to move to counter its own orbit in space. So that's why the thing curves against the background. But researchers gathered 37,000 Hubble photos taken over the past 2 decades. They got 10,000 volunteers from around the world to inspect the images and flag those with potential asteroid trails. 2 million identifications later, the team found 1,701 asteroid trails, of which 1,031 were previously uncatalogued.
Ooh,
The work also flagged 45 other objects as potential comets. So this is one of the pictures with the asteroid pattern on it.
and you don't
That's
know
been
the-
enhanced quite a bit. They've drawn in those lines showing where the asteroid trailed.
Yes,
It's a culting.
yes, if it was this pronounced, they wouldn't have needed to have 10,000 volunteers go over these things.
Okay,
Chuck, do you ever do any of this type of research with them?
No, this is more a Zooniverse type thing where you're looking through archived photographs.
Oh, okay.
would it be possible
is-
to say, gentlemen, that anytime it's a Hubble photograph, there's gonna be 4 spikes on the big stars, and if it were a Webb, there'd be 6?
Yes.
Uh-huh.
Yes,
Ah,
this is a lake in Chile that was felt to be very Mars-like. And since we don't have any pictures of Mars emitting methane, that's the picture that NASA shows for their discussion of the paper they published the last few days of where the methane comes from on Mars. And the idea, the strange thing about it is that, as you know, methane is periodically spotted by by surveyor as it chugs around Curiosity rover, as it chugs around Gale Crater. It can periodically pick up bursts of methane. There's a satellite going around Mars that is the European Space Agency's ExoMars Trace Gas Orbiter that has never detected methane on Mars. And the other rovers don't detect methane, but that's because they don't have methane detectors on board.
But Jerry, if you look real closely on the horizon there, I see a
Yeah.
cow. I see a cow.
Oh, I see
Oh,
a tourist,
yeah, we're off to the left there.
I see a tourist spot on the edge where you can pay to see the crater.
So what
But,
would that be? Olympus what?
Is this a good thing if there is methane? We don't use methane and rocket fuel to be able to come
Well, it
back.
gets people excited because methane is frequently produced by living organisms.
Mhm.
Oh,
But there's no evidence yet of any living organisms. So, and there are natural sources, volcanoes and other processes that will produce methane.
right.
But
And
why
Ron,
does- why
methane
does
is
ro-
used as a rocket fuel.
Oh, it can?
Yeah,
Well, there's plenty of it on Titan.
yeah. But on Mars, they want to know where it came from. And so what they figured out at NASA is that the methane from whatever source, life or volcanoes, is trapped underground with a layer of salt in the soil that forms a barrier that keeps the methane contained. And as the rover goes over it, the weight of the rover's wheels breaks through that crust and releases bits of methane here and there.
Possible decaying vegetation, Jerry, or is it possible?
It's
They're not speculating on the source of the methane. They're speculating on how this surveyor sees it. And
Okay.
it's because the weight of the rover is crunching through the seal where it's holding the methane.
Oh,
And then
wow.
as the wheels go over it, they can get a burst of it that comes up, and that's why this one sees it.
God,
When
that
the
little. That
Scanning
little.
the atmosphere doesn't see any methane.
But is
And
it,
and Tom or Tim, methane is a byproduct of metabolism of bacteria and stuff. So that's why they're very interested in it.
is
Yeah.
is it cold enough on Mars to make it liquid like Titan, or is it
no.
a gaseous state?
No, it's gaseous.
Not enough.
So it's like a gas. It's a gas
Yeah.
on this.
It's
this
natural
yeah.
gas.
world.
Yeah.
Okay, wow.
Well, Tom said it. There's a cow out there.
That's right, farting away. Whoa, the stuff we learn on this program. Are we down to the end? We're approaching the 60-minute mark. We are pretty close to the end. I guess we covered it all. Amazingly enough, you stretched to a little less than we normally have, but some great stuff nevertheless. Can we have a quick recap from our outreach guy on what's coming up, including this Friday night? Your impressions to tell everybody?
What's coming up Friday night? We have a speaker, Dr. Martinez, about the proliferation of satellites and space junk. And that's at 7:30 at the Museum of Natural History in Fleischmann Auditorium. Then Saturday, the 11th, is the monthly public star party. Tuesday, the 14th, is Telescope Tuesday at Commuter Rail Marketplace. But we're getting into weeks away, so we can cover that at other weeks. Although I might not be here next Monday. It's our anniversary, so Pat will probably whack me over the head and keep me from doing this.
And then you're going to go in and lay on an operating table at some time.
You're forgiven.
Well, gentlemen, as
Are
usual,
they gonna have the planetarium open coming Friday at 7?
The planetarium is probably not going to be open until at least September and maybe March of next year.
Wow.
what the heck are they doing? I thought they had it all refurbished.
Well, the planetarium's fine. It's the building that it's in that they're refurbishing.
Oh, okay. They don't call it an IMAX type
Yeah.
format, do they?
No.
No,
Kind of what it is. Well, gentlemen, you awestruck me. Thank you. Let's do it again in a week for number
Thank you.
160.
Thank you, Ron. Thank you, Jerry.
Yeah.
Thank you,
Thanks,
everybody.
everybody.
Take care of yourselves and your lovely wives. We'll see you Friday night at 7:30 at Fleischmann Auditorium for Dr. Larry.
Okay.
Take care, everybody. That's it for the Astro Hour.
All
Appreciate
right.
it.
Bye.
Bye-bye.
Bye now.